Hi, we're so happy you're here. Thank you so much for coming. My name is Catherine Carter, and today we're going to be learning about the PhET sim called Center and Variability. It's a simulation, and we're going to talk a little bit about what PhET is, but essentially we're going to focus on facilitation moves, specifically surrounding center and variability, that help empower learners as they learn really hard concepts of, well, not so surprisingly, center and variability. So my name, as I said, is Catherine Carter. I came to PhET last summer after 20 years in the high school classroom teaching math and statistics. And the reason I joined the PhET team is because we share similar methodologies and I guess ideologies of how students learn, and being able to learn through play is very powerful to support student agency and confidence. So we hope that you enjoyed today's webinar. I'd like to introduce my colleague and friend, Dr. Amy Rouinfar, who will be running the chat and the Q&A. So Amy, you want to introduce yourself?
Sure. Thank you, Kathy. Hello, everyone. I'm so glad you were able to join. My name is Amy Rouinfar, and I come to PhET with a background in physics and physics education research, and I work on the design of simulations. Today, I'll be here helping Kathy out with the chat and the Q&A and getting to engage with you all. So welcome.
Great. Okay, fantastic. So today our objectives are to learn a little bit about PhET sims and some background information. And then the bulk of our work will be in the center bullet of exploring how the simulation center and variability can contribute to student agency and creativity through powerful facilitation moves. And then towards the end, we're going to learn about resources to support teaching with PhET statistics sims, but really all sims. So that's what our work is for today. This is an interactive session, so we will encourage you to use the chat as we ask you to interact and play with the sim. It's very fun to play with the sim, so we really encourage you for that. If you do have questions, we encourage you to use the Q&A, and Amy, as we said, will be working, looking at that. You can also raise your hand, and if you do, we can give you permission to speak if you prefer not to type. You can use the chat for questions, but remember, we're going to be asking you to interact with us through the chat, so sometimes questions can get lost. So if you do have a question, we do encourage you to use the Q&A. So what makes PhET sims unique? First, we are research-based. That means that we look to the literature that's out there about the current education on the topic we're designing a sim around, and we create learning goals by partnering with pedagogical experts like yourselves and our internal pedagogical team. We have an initial design, and between initial design and final design, we do a lot of iterations, including interviews, classroom observations, whatever comes out of that. If students don't find a button or don't interact with the sim as we intend or expect them to, we will do redesign. And between initial design and final design, it takes approximately 1 year. If you do a Google search on Google Scholar, you'll find approximately 71,000 articles related to PhET. As an example, this is a classroom research that looked at the knowledge of fractions in fourth graders, for both procedural and conceptual knowledge. A little bit of background for this classroom study was that the students were given a pretest in October. The very following week, Monday through Thursday, the students were shown a lesson only 20 to 30 minutes per day using a PhET simulation on fractions. And then on that following Friday, after only 4 lessons, 20 to 30 minutes long, with no intervention from the teachers, they took a post-test, and you can see that both their procedural and their conceptual knowledge increased quite significantly. Not only do the PhET sims increase knowledge, procedural and as we said, the conceptual knowledge, but the sims also have an impact on the discourse in the classroom. For the same teacher with the same set of students, the same year, observers looked at a teacher, the same teacher, teaching a lesson with and without sims. And the researchers noticed that when that same teacher taught with no sim, the standard procedures and recalling facts were the focus, whereas sim lessons were more focused on the student exploration, exploring their own ideas, inventing strategies, and collaborating with each other. In general, PhET sims are very engaging, intuitive, dynamic, research-based. There are multiple representations of the same concept in sims and often grounded in real-world contexts. We have on our website almost 170 simulations, of which 108 are converted to HTML5 or were built that way. And the most important thing is that we are an open education resource, meaning we're free. So we're grant funded and supported by not only grants, but donations and partners. We have sims in physics, chemistry, math, or science and biology with over 3,000 teacher-submitted activities that are pre-made and ready for you to use. We're going to look at one of those today, and translated into over 100 and into 100, more than 100 languages, and can be run online or offline. So without further ado, we'd like to engage you in our sim of the day, which is Center and Variability. So you're going to engage in what's called open play. Amy's going to put the link in the chat. When I prompt you, after you investigate for a few minutes, we want you to play with the sim. And we'll invite you to write 2 to 5 things that you notice or wonder about in the chat. And I'll say, hey, for the median screen, what do you see? For the mean and median, what do you see? And for the variability screen, what do you see? And then in general, so we can focus what we have. So Amy, I'm not sure if you have everyone or just host and panelists, but if you can put the link in the chat for everyone, that'd be great. Excellent, thanks. So please feel free, and we encourage you to play with the sim for just a few minutes, and then I'll ask you to invite you to write 2 to 5 things that you notice or wonder about. Your goal is to discover features. As you play with the median screen, I invite you to type in the chat things that you noticed about features or things you wonder about on the median screen. What have you discovered so far? I will say I'm not giving you probably enough time to play, but in your class, you'd give your students a little bit more time. Can't see the link. If you can't see the link, there's a tab in the chat that says either everyone or hosts and panelists. And if you change it to everyone, you should be able to see the link. Did you find it, Krista? Hopefully. Yeah, Zoom defaults to the hosts and panelists, so. So when you're ready, go ahead and start typing into the chat some things that you're noticing. Oh, excellent. So as you're typing, I'll kick some. Probably notice that there's sound. I'll turn my sound off temporarily so it doesn't interfere with yours. So if you can be specific, are you talking about sorting the cards or the balls? guess you don't sort the balls, but data checkbox. Oh, this thing up here. Okay. You can also manually sort the cards, but you can click this box and it'll sort it for you. Very nice. Students love sorting the data by themselves because you get a little confirmation that you've done it correctly. And students love that little Easter egg, if we call it, that you can do that. Hopefully you notice that if the data is unsorted, it gives you the median. And if you sort, it tells you where the median is or how it's calculated or where it exists in the data set for even and odd numbers. Perhaps you notice that there's a predict so that you can move this and you can predict where the median might be before you decide which ball it is. How about the mean and median screen? What did we notice about this screen? Visually appealing for students and allows students to change the amount of data and then can predict and check their answer for the true median. Yep, and that's true on both the median and the median. And on this screen, you can add to that the predict mean. And notice that the mean is a more smooth, whereas this is it snaps to a half intentionally since the median can't be anything but the half. These are all intentional design features of the sim to help the students get a sense of feasibility, but also that the mean is a much more fluid measure than the median. You can see how the median is calculated. And Rebecca says the students can find the definition. Are you talking about this info button, I'm assuming? All screens have an info button where you can see where the median is. Notice the visual cues are consistent. Where the median and the mean, it tells you how they're calculated and visually shown on the number line. Notice that it also copies the number line exactly from what you see here on the field. So it's not a static visual just picture of any data set. It actually calculates the data, the mean and median for the data that you have on the screen. If you kick all of the soccer balls, do you notice the median updates dynamically? If you click off the median and back on, it'll show you how to find the median and the mean as balancing point that you can point out. If you notice, there's a cue here on the soccer ball as well. So on all screens, not only can you sort the cards on the median, but you can also move the ball to anywhere you want and create a custom data set. So this is a feature that's very nice to have here. How about the variability screen? This is a pretty complex screen. It's got lots of things to push and check out and try. What things did you notice and what features did you find on the variability screen that you can type in the chat here? Oh, Tyler, I have an answer for you in just a moment. Tyler's asking if you can change the number of kicks on the field, say from 1 to 10, see the change of amount of data really changes the mean and median. So what Tyler's question is asking, you can actually find down here in the settings. So if you click on the settings, there's a simulation tab and anything customizable for the simulation you can find here. You can change the plot type from X's to these dot plots. Here's where max kicks. It's not a slider, but you can change the maximum number of soccer balls that you have access to, anywhere from 5 to 30 in increments of 5. So you have both even and odd numbered choices here. The default is 15. For the box plot, you can see the outliers or not. There's also a visual tab if you have students with needs like interactive highlights for low vision students, for example. Here, this audio is the same as this button down here. And this is, you can change the region and culture of your character set. So in the settings tab, there are lots of choices there. So thanks for asking that question. Okay, any other things that you want to point out? This info button is on all screens. Okay, so what you have discovered for the open play is basically all centering around our design features when we create a sim. All of our sims are highly engaging. If you notice, there are no instructions to tell you how to use the sim. There's no box that pops up that requires you to read how to interact with it. And from that, we have an intuitive interface that invites you to play with the sim. There are lots of buttons to push, lots of checkboxes to test out. There's info buttons and lots of things to think about. Guiding question up here at the top. It's just an intuitive interface that makes you want to play. Oops. We have accurate and dynamic representations that update in real time. So you can see that the mean is displayed both as a balancing point here in this picture, shows you where the mean is on the triangle on both the field and the number line, and tells you the value of the mean rounded to the nearest tenth. There are pedagogically powerful actions that exist in our sims, and essentially those mean that we incorporate things that are not usually allowable or can happen in real life. For example, the mean updating dynamically and showing as a balancing point, the balls being able to be moved along the number line, and stacking like a dot plot is not something that soccer balls would do, defying gravity. So these are what we call pedagogically powerful actions. And we also design the sims to have implicit scaffolding where we know that most people are going to look left to right, top to bottom. So we intentionally put the prediction checkboxes above the median and the mean actual checkboxes to encourage students to make predictions before they actually engage. There are other design features, but here are some pretty important ones. So what we're going to do next is we're going to actually experience a lesson. And the goal of this is to do a deep dive into the lesson specifically designed to help you engage in and feel the pedagogical moves that help support and empower the learners so that the students feel agency in their learning experience. So we're going to go through as your students would, and we're going to experience what's called a guided inquiry lesson. All of our lessons have learning goals. So for this lesson that we're going to be going through is the learning goals are to describe general variability of a distribution based on the box plot. So we're going to be focusing on the variability screen and on the box plot, what we call a radio button, because you can't have more than one picked at the same time. And the other good learning goal is describing what the interquartile range is measuring. So this is what your students would experience. You've just engaged in open play, and this is the first component of our guided inquiry lesson. There are essentially 4 components to the guided inquiry lesson. We're going to go through each one and the facilitation moves that go along with it. So for open play, you just engaged in that. I would like for you to type in the chat, what benefits do you see for open play? Why do we do this in the simulation, and why might it be important in your classroom as you ask students to engage with lessons? So take a moment to write down a couple things for what you see for benefits. Allows for students to play with the sim before your lesson, so they will hopefully be less distracted. Absolutely. I mean, if you're trying to explain the sim and you give it to them, they're going to be playing with it while you're trying to talk, and they will not be listening to you. So that's an excellent point. Thank you for that. What else? Better understanding for the sim. When you give instructions, they'll know what you mean. Students recall things like mean and median and better understand when they're able to experiment for themselves and play. Absolutely. We call each of those where the students are essentially, they're building agency, they're building confidence, they are creating ownership over their learning and the simulation. Absolutely. Anything else? Another thing that this open play does is it sets the student's mindset into a I want to explore mindset, so that when you ask them to do something, they feel very open to explore. Sometimes if we're the ones to tell them how the simulation works, rather than them being able to figure out how the simulation works, is then they think that the buttons that we tell them about are the only ones that they're allowed to touch. So by giving them the opportunity to touch anything and everything that they want, move whatever they want, play with whatever they want, then they feel free to do so. So when you do ask a question, they're more open to exploring their own ideas, creating conjectures, and exploring those. It encourages collaboration. You'll find that when students are in open play, they start turning it to their neighbor and saying, hey, did you find this? Oh my gosh, I found that this happened. Did you see this? And they'll try to teach each other how to use the sim, freeing a lot of time up for you. Essentially, the bottom line is that they feel like they're the experts of the sim, which then allows you to create a very important and focused lesson environment. We're going to look now at the open questions utilizing the sim. The goal here is that we actually use the sim. These questions are really hard to write. I taught for 20 years in the classroom, and I still find these a little bit challenging to write. So I'm glad you're here so that we can go through what a question that utilizes the sim might look like. The point is that you want to write questions that students cannot answer unless they're using the simulation. So for example, on the variability screen, so Amy's going to put a different link in the chat. It's a customized URL to focus your attention on only the variability screen. If you don't want to click that link, it's fine. You can stay on the variability screen where you are, but I do want to show you that you can customize a URL. I'll show you how to do that later on. But what this does is helps the students focus on the variability if you want them there and not on the mean screen or the mean and median screen, excuse me, median screen and mean and median screen. So your job is to look at the box plots and try to create soccer ball distributions of kicks that create box plots similar to the ones shown. And in a few moments, I'm going to ask you to enter into the chat, describe the distribution of what do the soccer balls look like to create these box plots. So go ahead and play for a moment, and then I'll ask you to type in by letter A, B, C, D. How would you describe these? You don't have to type A and then B. You can say, well, A is this versus C is this or something. But play for a little bit, see if you can recreate these box plots, making sure that you're on the variability screen here with the box plot radio button shown. And when you're ready, go ahead and type some descriptions of these box plots and what does the distribution of the soccer balls look like. In your classes, you might have to do a little bit of pre-knowledge of what a distribution is. At this point, I would assume that we've done that. So maybe when we're thinking about a distribution, we're thinking about how the soccer balls are distributed or divvied up. And when you type in the chat what you're thinking about, use whatever language that makes sense to you. I don't want to drive your language. At this time, I expect informal language, and if some of you are comfortable, some more specific language. You could also write comparison statements, like A is very spread out, clumps of soccer balls at the first and third quartiles compared with B that has or something. You can also structure your language like that. A, B, and D all have similar ranges. C has a very different range, but very different distribution. C has all the data clumped together closely. Notice that I didn't put a number line on any of these box plots intentionally to encourage you to create these box plots in whatever that looks like. D is weighted toward lower values. More of the data is down there on the left. So the point of this question is to encourage students to figure out the pieces and how the distribution of the soccer balls using language like more spread out or clumped together or clustered, or there's a gap, I can make a gap here, or larger range from low to high or something like that. And depending on where you are in your lesson, there you might encourage students to have very informal language like the soccer balls between the minimum and the first quartile are more clustered in A than in B. B and C have the bulk of data clumped together, but slightly lopsided. D is more clustered. Yeah, it's all these informal languages. As you move into the lesson, you can start building that vocabulary. And once students want to use a word like, I really want to describe this thing right here, but I don't know what it's called, it gives you a great opportunity to say, oh, that's quartile 3. And they'll say, oh, okay, thanks. And then they can keep going. Giving them the vocab in the moment when they need it helps them remember it a little bit more. So as you're going through here and using the language, whatever it is that is at your education, journey at that time, you can introduce those vocabulary words as they come. Okay, excellent. Notice that tables are often used in inquiry lessons to help the students really feel free to organize their thinking, compare what they have, and it allows you to quickly go around and observe what students are doing or thinking about. So this next one, it says, notice that the arrows pointing to the components of the box plots. So here, notice that the box plots are all equal. They're all exactly the same. That is just to guide your attention to these arrows, and the components of the box plot is what I'm going to call them. So now, before, you were able to explore these components freely without needing or wanting the vocabulary, really. And here we want to focus on what moves these values. Again, the vocab is something you could introduce now or later, and the level of complexity for the vocab is up to you as an instructor. But I encourage you to try to figure out what soccer ball in your distribution has an impact on the pieces with the arrows on them. So go ahead and explore for a moment or two. How would you describe those data points that can impact the components of the box plot that have arrows? So Krista says for A, the shortest and the longest kick can move these guys. How would you describe the data point that moves this for B? B and C are a lot more challenging. Doubles and triples have a strong influence. And by that, Rebecca, are you meaning stacks of more than one? We have a question. I think you can unmute yourself. I don't think I can unmute you. Abduli, you can unmute yourself. I'm not sure if I said that correctly. So Abduli, go ahead and ask your question. You just need to unmute yourself. Go ahead when you're ready. Move B, it helps to move a ball from the lower half to the upper half. Okay, so noticing that this might be a halfway point. These are really hard to describe in part C. Notice that the level of complexity is increasing. So perhaps at your level of when you're ready for students, whether you want the students to be informal in their language or more formal in the language, you could use shortest kick to farthest kick. You could use minimum, maximum. You could use the left edge and the right edge, whatever you want to use as your words to help connect with what the students are thinking about. That's your, professional discretion. Here is, you can say, move a ball from the lower half to the upper half. You could say something like the median. You could say quartile 2. Anything that in the level of depth of the vocabulary would be good. These are much more challenging. You might say the soccer ball between the minimum and the middle, or a soccer ball between the middle and the high, or something is a more informal way to say maybe the middle. I've figured out that this ball has to be the middle of the bottom half or the middle of the upper half, or maybe if you're ready, you could say quartile 1 and quartile 3, depending on what you have shown. So we're gonna wait one more moment, see if we can get Abduli to. Nope. Abduli, if you could type your question in the chat. I think we're having trouble with connecting to audio. Yeah, it's almost more interesting to see what ball doesn't change quartile 1 and quartile 3. In fact, back to Tyler's question earlier, depending on how many balls you have in your playing field can also impact how easily it is to move these arrows. So all of these are excellent discussion points that while your students are playing, you circulate, you listen to their conversations, you can figure out what they're thinking about, how many students have a ball, like 4 soccer balls on the field versus 15. And you could ask students to, I should say 5 or 15. You can ask students to share their screens, or in your debrief, you can talk about, pick certain students to share what they discovered. And yeah, it's using the sim with 20 is a nice conversation that divides equally into exactly 4 pieces, which is an excellent thing. And Abduli, if you can figure out how to unmute, you can go ahead and start talking. And I'll go to this screen in the meantime while we figure that out. The last table here is sketch your favorite or interesting examples. Determine how the value of the interquartile range is calculated. What we can do is, if you notice, there's a toggle that you can toggle here to give the value, but you don't have to have that value if you don't want to. So you can encourage students, if they're struggling, how is that calculated? How do we find the value of the IQR or the interquartile range using the sim? What happens if you move a soccer ball to the interquartile range? Can you make it stay the same? Can you figure out how the interquartile range is being calculated? Then you can draw some interesting box plots here. So here's your goal. And when you're ready, type in the chat in your own language, describe how the value of the interquartile range is being calculated, also known as the IQR. So the facilitation move of inviting people, your students, to discuss why they found something interesting, what made them draw that, how are they going to be engaging with this sim. So take a couple moments to type in the chat in your own words. Whatever makes sense to you. How is the IQR calculated? The width of the box, the distance in meters of the sides of the box. Noticing that the box has something to do with it. Nothing's happening here. Nothing's happening here. Nothing's happening here. So trying to figure out how do I make it change? Oh, there it goes. So what happened and how is it following? How is that value following the distribution of the soccer balls? Is a really interesting conversation and goes back to part C about what drives these values in the box and how do we describe that when we're describing how the value of the IQR is calculated. And the sides of the box don't always line up with a certain ball. It can be sort of depending on how the distribution is shown. The edges could even be at a halfway mark if I have an even number of balls. Lots of things to explore here. When you are thinking about the interesting examples, you can highlight some of the students, ask them to come up and recreate their distribution in the class. In the chat, what benefits might you see for the students playing around with guided inquiry? And in the interest of time, we definitely did not go through, as a lesson, because I would have the students go up and drive the sim to highlight. I would be circulating to try to find interesting examples like this one. There are a lot of different ways that you can ask the students to become the drivers of the sim and the whole class debrief. Why would you want to do the guided inquiry? What did that do as you were engaging with them? What did it do for you, not only with the sim, but also with your understanding of box plots? Yeah, and Abduli is noticing that the interquartile range is calculated on two things. Number one, it requires you to know the number of kicked balls and also how they're spread out. So the box tells you how spread out the data set or the distribution is. So guided inquiry helps dig into the deeper definition of terms and how you would truly use them and what they might mean. This sim can focus on sense making, gaining intuition over the interquartile range. It can lead students to new understanding how any specific data point can or can't influence the components of the box plot. Yeah, box plots are used in statistics all the way through life. This isn't something that's just a middle school standard. It's a very important thing used a lot in statistics, in studies and research studies. So box plots are something that are really important. As you wrap up the each of these and you go to a class discussion and you highlight the ways that students are thinking about these, you can start building that vocabulary of the components of the box plot, even as early as this. The whole point to this particular screen is to encourage students to notice how spread out the data set is and that the soccer balls can actually impact how the box plot looks. Here we focus even more on the components of the box plot after they've thought about the distribution. And here, now it's more free. You can play around, you can have students make conjectures, test out their conjectures. And now we're getting to how the IQR is calculated. And the number line, the numbers can help, like, 4 to 12. We can say that if the box goes from 4 to 12, or 3 to 10, that the IQR is going to be 7. I'll share when I was doing interviews, a student was playing with the sim and she would keep this off and she would erase, change a kicker, and she liked that the kickers have different distributions. I'll share with you that kicker 1 has a very narrow spread and a unimodal type thing, even though where they actually land is randomly decided. Kicker 2 also has a somewhat symmetric distribution, but a much more wider spread. Kicker 3 is skewed to the right every time. And kicker 4 is skewed to the left each time. So you can get outliers with each of these. You can have different discussions of who's more likely to have a higher IQR between these kickers. The student I was interviewing noticed that these kickers have different distributions. And she would say, for example, this box plot from 3 to 7, she would say, I could hear her talking. She said the IQR 7 minus 3, that's 4. And she would click this box and go, yes. And she was checking her conjecture and she was very proud of herself for getting it right every single time. It was pretty fun to watch. So students love making predictions. When you're finished with this portion of the lesson, you can check for understanding in a quick summary. You can either do something like I did, even though you're summarizing as you go. You can summarize perhaps by asking some multiple choice questions or more open-ended questions. Here are a couple multiple choice question examples where you review the learning goals, make sure that students remember what the whole point of this lesson was, which was to describe the general variability of a distribution based on a box plot and describe what the IQR is measuring. So you could ask a multiple choice question if you had, say, Schoology or access to a Slido or some kind of interactive multiple choice resource. You could ask a question like this. One way that you can interact with multiple choice questions is have students answer. You can have them discuss before they answer, or you can have them answer individually and then have them discuss the 2 or 3 answers that were most common before you reveal the answer. And then have them discuss with each other pros and cons or why one might be more correct than another. I'll show you where you can find a little bit better description of that called concept questions on our website. But really, these questions are meant for you to make sure that the learning goals have been met, as well as quickly and formatively, not summatively, but formatively assess whether the learning goals have been met. So here's a very rote question. What's the value of the IQR with intentional distractors of the minimum, the quartile 1. Here we have the actual IQR length of 5. We have the median, and then we have the quartile 3 here. So intentional distractors to encourage discussion. The summary check for understanding can also be open-ended questions. For example, which distribution is more variable? Both of these could be the correct answer, but the point is to inspire a discussion, whether you're doing that through multiple choice questions or whether you're doing that through open-ended questions. Here, describe what the IQR is measuring. You can ask that. What is the IQR measuring in your own words? This is directly connecting to the learning goals to formatively assess whether they've been met. And give the value of the IQR for this box plot. So asking these types of questions, if you're familiar with the depth of knowledge chart, these checks for understanding are hovering in the 1 to 2 or not quite, not super challenging questions, where the knowledge synthesis we'll talk about in a moment is more about the depth of knowledge 3 and 4, where students are going to apply their knowledge to something new. So just quickly, what benefits do you see for summarizing a lesson and formatively checking for understanding? Quickly check, type in the chat what you might think. Yeah. One of the things that we love about PhET Sims is that they're so fun to play with that students love talking about the Sims to each other, and they're talking math. Back to the research in the classroom for discourse, students are talking math more minutes when a simulation is being used. It reinforces the concepts that they've learned without you directly telling them, so they internalize it a little bit longer. You can make sure that students have learned the same thing by the end of the class. It's a great way for students to self-assess whether they've met the learning goal, which is an important step in building student agency. Essentially, the most important thing is that you are finding ways to formatively assess, not summatively, but formatively assess, and having the students self-assess whether they've met the learning goals. Yes, exactly. Self-esteem, confidence, agency, all of those feed into students feeling more empowered in the math classroom, which was the whole, well, that's the title of this session. So yes, thank you for noticing that. Okay, so finally, the knowledge synthesis portion is where you extend their knowledge into the depth of knowledge in the 3 and 4 category, where you ask them to apply their knowledge to something new and create like a synthesis, which is why this is called synthesis. The definition of that is to create something new. You can do this in a think, pair, write, share format or as homework. You can explain the possible impacts on the IQR when the minimum value is changed. There are lots of different answers that could happen here, depending on how many soccer balls you have on the field, depending on whether you have an even or an odd number. If you have a lot, if you don't have very many, what happens when the minimum value is changed? If students can answer that articulately, that's a word, then you know that they can extend their knowledge to something new. Is it possible for the median to be outside the box? Create 2 different box plots where both have a median of 6 and an IQR of 4, and then talking about if this is possible, do it. If not, explain why not. So all of these could be knowledge synthesis. I'm sure that you can think of a lot more questions you could ask as well, but the point of this step is to really make sure that students can apply their knowledge to something else. So if there's something else you want to type in the chat that I didn't say, please do. I have a couple more if you don't, but. So a couple things that I really think knowledge synthesis is good for, especially if you use it as something that you really can tell which students are ready for extensions. I'm sure you've heard the phrase low floor, high ceiling. You can tell which students are ready for the high ceiling questions. You can tell whether the higher order thinking has been applied. You can really tell which pieces of your learning goals need some reinforcement or something that you need to develop those skills and knowledge a little bit more deeply. In summary, and I have a couple more, so don't leave because I need to show you where to find these resources. The guided inquiry lessons are built with intentionality. The components of open play, guided inquiry, summary, knowledge synthesis have specific and intentional facilitation moves to really help you dig into the content and help students make connections, agency, confidence, and feel empowered in their own learning to take ownership over the sim and their learning. So in open play, listen to, notice, select, and sequence ideas. Think, pair, write, share. Usually we say think, pair, share, but I encourage you to, incorporate the write component as well. Let students tell the mathematical story. The tables are a great way to organize the guided inquiry portion. Here you want to have a discussion. The most important thing about the summary is discussion. And the knowledge synthesis is really that you now can learn how to differentiate and know where to remediate. Other sims for statistics, we talked about center and variability. We also have least squares regression for those of you who are engaging with scatter plots and want to have a line of best fit. These are checkboxes that you can check on or off if you don't want students playing with that. We have Plinko probability to engage students in probability, binomial distributions or distributions in general, or how histograms are built. This is a new sim. This screen you can access on our website. It is a prototype, and 3 more screens are slated to be published later this year. The point of this is to get students to be thinking about what is the meaning of mean. So that sim is called mean, share, and balance. On the PhET website, when you go here, and Amy's going to put the link in the chat, this is our home page. You can either get to the simulations through this tab and clicking on math, or by clicking on these circles down here. When you click on these circles, this is automatically filtered by math. You can also filter by grade level. You can also filter by inclusive features. We have tab is alt input. We have some sound and sonification, as you saw in this sim. Some of the sims have voicing, so you can also filter by inclusive features or locale. If you are working with some Spanish students, it translates all the sims into the language that you're working in. So if you click on Center and Variability as an example, on our website, we have what topics you might teach with it. Some sample learning goals. We all know that administrators love to have learning goals or objectives posted. So you can have take these if you need. They're, we write them as well. So they're high quality to match what the sim is about. We also have standards alignment and which inclusive features are included in each of the sims. To create a free account on PhET, you can do that, and then you can see some of these resources. Here's a PDF to make sure that you see all of the pieces of the sim that you may or may not have missed. Some suggestions for use, some sample challenge prompts in addition to those learning goals. And I told you I would tell you about how to make the customization options, and here's where you can find instructions on how to do that. You can, anything in the settings, you can make as what's called a query parameter. So for example, if I were to type on here, I want to customize this sim and I want to have only the median screen, this document tells you how to do this, and I can say screens equals 1, and now you notice that I only have the median and I don't have the others. So here's how you can customize a URL where you copy that URL and paste it directly into your learning management system for students to access. Never a login. PhET sims are free and never require a student login so that students can get playing immediately with no extra steps. That's where you'll find these customization options. For all sims, you'll find a table like this. If you want to do more than one, for example, if you want to show outliers, if I want to have on screen 3, so the question mark says, I want to customize the sim and I want to customize it in this way as well. So it's case sensitive, so you'll want to make sure that you're paying attention. But this one, first question mark says, I want to customize you. And then I also want to customize it in this way. And if you wanted to do another one, you do another ampersand. So now if I go to this box plot, I can see that that outliers checkbox has been activated automatically. So when students are to click on this link, then they automatically have all the settings that you wish. Also here on the About tab, the activities is where you'll find the activity we went through today. And if you click here, you'll see that there's a student handout version and an annotated teacher guide to help you understand and kind of relive what we did here today. Amy put a link in the chat for you. Please complete this short survey. And as we go through, if you have any questions, you can definitely email us or type in the chat. And I made a Google Doc. Amy also put that link in the chat that contains all of the webinar links. This is what it looks like for you for the Center and Variability, the mean, share, and balance, Plinko probability, all the math sims, all the Center and Variability. So please fill out the very short survey. It should take you no more than 2 minutes. And to go ahead and take that survey. We appreciate your time. And I will leave this up for my information, Amy's information, and where to find us on Twitter, not called Twitter anymore, and Facebook, and our website. So thank you for joining us, and feel free to stay if you have questions. I know we have one, or you can type them in the chat. Thank you so much for your time today.